Hello, my name is Roth Powers, and today I will be discussing with you the history of the periodic table, and I will talk a little bit about atomic trends. The learning goals of this short 5-minute video will be to have a brief understanding of the periodic table, so we can then understand the history of the periodic table, and to have a little bit of an understanding of atomic trends. Then I'll do a quick review of everything we learned at the end. The periodic table is an arrangement of all 118 known elements. These known elements are arranged in periods and in groups. The lightest elements are at the top, and the heaviest are on the bottom. Periods are arranged horizontally across the periodic table, and all have the same number of energy shells. Groups are arranged horizontally. Their elements in a group all have the same number of valence electrons in their outer shell. So all of these elements are in one period, and they all have the same number of energy shells. All of these elements in this group are arranged vertically, and they all share the same number of valence electrons. Dmitri Mendeleev was a 19th century chemist and theorist who was influential in the creation of the periodic table. During this time, the 60 known elements were arranged in atomic weights, with the lightest at the top and the heaviest at the bottom. But Mendeleev and a couple of his closest peers sought to create a better table. They created the first periodic table, which wasn't arranged by atomic weight, but arranged periodically. At the beginning of this new table, the characteristics of the 7 elements repeat. As the mass of these elements increased, the periodicity started to look less periodic. This is where Mendeleev's genius really shined. He realized that periodicity started to look less periodic because the table was missing elements that hadn't been discovered yet. Mendeleev was so certain he was right, he predicted the properties of the missing elements in the periodic table. As an example, he predicted germanium and gallium, which I'll talk more about in the next slide. But these all had the same periodicity in the first 7. 2 examples of Mendeleev's predictions are echelonium and ecosilicon. He predicted the atomic masses, melting points, density, and all others without ever actually observing these minerals, and we know echelonium as gallium today and ecosilicon as germanium today. Atomic trends. Atomic trends are basically patterns in the periodic table. So up here, the radius of this atom, of helium's atom, will be itty bitty, but then as you go further left and further down, the radius will get bigger and bigger. So the radius here will be pretty big relative to the radius here. Just to quickly summarize what I've covered in this quick 5-minute video, I've talked about the periodic table of elements, which is a display of the chemical elements which are arranged by atomic number and recurring chemical properties. I have also covered the importance of Dmitri Mendeleev in the predictions of future elements and the atomic trends that can be observed inside of the periodic table. All of the graphs and tables in this short 5-minute video were gathered with a Creative Commons license. Thank you.